there is a place your mind visits every night, a world that feels entirely real, yet exists only within you. And tonight, lying exactly where you are closer to understanding it than most people ever pause to consider. Welcome to Sleepless Scientist Night. Wherever you are right now, perhaps feeling the familiar weight of your pillow, the quiet settling of the room around you, allow yourself to sink into this moment. Tonight, we will drift through the corridors of 100 dream science facts about lucid dreaming, from the first flickering moment of dream awareness, to the hidden architecture of the sleeping brain, to the threshold where consciousness and sleep quietly dissolve into one another. These gentle journeys through the science of dreaming build a quiet community of curious minds. A soft like, a subscribe, or a thought shared in the comments creates a pathway for more dreamers to find their way here, and brings us closer to tending to this peaceful space, one sleepy soul at a time. Your presence here tonight means more than you know. Now let yourself settle completely. Feel the weight of your body releasing into wherever you rest. There is nothing to solve tonight, nothing to remember. Let these thoughts of dreaming drift gently past you, like images forming at the edge of sleep, soft, unhurried, already beginning to blur. Simply breathe. Simply rest. Close your eyes and breathe deeply. You are floating where memories rest safely in the spaces between thoughts. Let your mind merge with the quiet that lives just beneath waking. And now we begin. Lucid dreaming is the experience of becoming aware that you are dreaming while the dream is still unfolding around you. It is not a fringe phenomenon or a mystical state. It is a scientifically documented condition of human consciousness that researchers have studied for decades. The term itself was introduced by the Dutch psychiatrist Frederik van Eeden in 1913, though accounts of people waking within their dreams stretch back through ancient Greece, Tibetan Buddhist tradition, and Aristotle's own writings. What makes lucid dreaming remarkable is its central paradox. The mind is asleep and yet, in some meaningful sense, watching itself sleep. That awareness, that quiet inner witness, is what researchers around the world are now trying to understand. The scientific confirmation of lucid dreaming came in 1975, when British psychologist Keith Hearne recorded the first eye movement signal from a sleeping subject using an electro-oculogram at the University of Hull. The first time a message had been consciously sent from within a dream and captured by scientific equipment. A few years later, working independently at Stanford University, psychophysiologist Stephen LaBerge conducted his own signal-verified experiments beginning in January 1978, this time using full polysomnography, combining brainwave monitoring, eye movement tracking, and muscle tone measurement, confirming beyond reasonable doubt that the signals were arriving from genuine REM sleep. His results, published in the journal Perceptual and Motor Skills in 1980, brought lucid dreaming formally into the landscape of sleep science. Lucid dreaming almost always occurs during REM sleep, rapid eye movement sleep, the stage most associated with vivid, narrative dreaming. REM sleep was first described in 1953 by Eugene Aserinsky and Nathaniel Kleitman at the University of Chicago, who noticed that certain periods of sleep were marked by rapid, darting eye movements beneath closed lids, increased brain activity, and a characteristic loss of muscle tone throughout the body. During REM. The brain's activity patterns on an electroencephalogram resemble those of waking consciousness far more than they resemble deep, slow-wave sleep. This is why REM is the soil in which lucid dreaming grows. The brain is already running at near-waking frequencies, and the threshold between dreaming and awareness is at its thinnest. Studies consistently suggest that somewhere between 50 and 82% of people have experienced at least one lucid dream during their lifetime. That number varies depending on how the question is asked and how broadly lucid dreaming is defined. What is clear is that this is not an unusual experience. Roughly 20 to 30% of people report having lucid dreams frequently, meaning once a month or more. Among younger people and those who regularly practice certain techniques, the frequency is higher. Lucid dreaming is, in this sense, a normal variation of human sleep experience, not an exceptional gift belonging to a few. Most people, at some point in their lives, have briefly woken within a dream without knowing quite what to call it. The brain regions most active during lucid dreaming form a revealing map of consciousness. Studies using functional MRI and high-density EEG have found that the prefrontal cortex, particularly the dorsolateral prefrontal cortex, shows markedly elevated activity during lucid dreams compared to ordinary REM sleep. This region is associated in waking life with self-awareness, logical reasoning, working memory, and the ability to think about thinking. During ordinary dreaming, this area is relatively quiet, which is partly why dream logic feels coherent while we are inside it and absurd only when we wake. During lucid dreaming, it reactivates. The sleeper begins, in some sense, to think again. And that thought is the spark that illuminates the dream. You can let that image settle gently. Simply breathe. The question of which brainwave patterns distinguish lucid dreaming from ordinary REM sleep has occupied researchers for decades. And the most recent answers are both more nuanced and more interesting than earlier studies suggested. An early and influential study by Ursula Voss and colleagues, published in the journal Nature in 2009, proposed that lucid dreams were associated with elevated activity around 40 Hz in the gamma range, in frontal brain regions, a frequency typically linked to high-level conscious processing. That finding sparked considerable scientific interest. However, a large multi-laboratory study published in the Journal of Neuroscience in 2025, pooling data across multiple research centers, found a more complex picture. Rather than a simple increase in frontal gamma, lucid dreaming appears to involve reduced beta wave activity in areas associated with spatial awareness and self-perception, alongside some gamma changes in the medial prefrontal cortex. The neurophysiology of lucid dreaming, science is discovering, is still finding its final shape. One of the earliest and most reliable techniques for inducing lucid dreaming is reality testing, the practice of regularly questioning whether one is dreaming throughout the day. The logic is simple and quietly elegant. If you habitually ask yourself during waking hours whether you might be dreaming, the habit eventually carries into sleep, where the same question, in the right context, triggers lucidity. Common reality tests include pressing a finger against the palm of the other hand. In a dream, the finger often passes through, or looking at a digital clock or written text twice, since dream text tends to change or blur between glances. Practiced consistently, These techniques appear to prime the metacognitive regions of the brain to remain active during REM sleep. Another well-studied induction technique is the mnemonic induction of lucid dreams method, known as MILD, developed by Stephen LaBerge as part of his doctoral research in 1980. The practice involves waking after roughly 5 hours of sleep, spending a short period of time mentally rehearsing a recent dream while firmly intending to recognize it as a dream the next time it occurs, and then returning to sleep. MILD works in part by exploiting the natural architecture of sleep, the long REM periods of the early morning, while using prospective memory, the same cognitive faculty that reminds you to pick something up on the way home, to plant an intention that can activate during dreaming. Controlled studies have confirmed that MILD produces measurable increases in lucid dream frequency. Wake back to bed is a related technique that notably increases the likelihood of lucid dreaming by timing sleep interruption to coincide with peak REM density. Because REM periods lengthen as the night progresses, the final hours of sleep contain the richest, most vivid dreaming. Waking intentionally after 5 to 6 hours, remaining briefly alert, and then returning to sleep increases the probability of entering REM directly, and of maintaining a trace of waking awareness as the dream begins to form. Research supports wake back to bed as one of the most effective standalone interventions for inducing lucid dreams, particularly when combined with MILD or other awareness practices. So already, even at this early point in our journey, something interesting is emerging. Lucid dreaming is not simply a quirk of sleep. It is a window into the architecture of consciousness itself, the techniques that invite it, the brain regions that enable it, and the timing that nurtures it all point toward a fundamental question that neuroscientists and philosophers have circled for decades. What does it mean to be aware, the dreaming mind? It turns out, may have more to teach us about waking consciousness than we ever expected. And we are only beginning. Allow yourself to rest with that thought. Gently, the wake-initiated lucid dream, abbreviated WILD, is considered the most direct path into a lucid dream and also the most technically demanding. Unlike dream-initiated lucid dreams, in which awareness arises from within an already formed dream, WILD involves carrying consciousness directly from wakefulness into the dream state without losing awareness during the transition. Practitioners describe entering a period of hypnagogic imagery, the geometric patterns, sounds, and dissolving scenes that occur at the edge of sleep, and then allowing those images to stabilize into a full dream environment while the mind remains deliberately alert. The experience can include sleep paralysis, a sensation of pressure or vibration, and vivid imagery before the dream fully forms. Sleep paralysis, the temporary inability to move the body upon waking or just before sleeping, is a natural feature of REM sleep that occasionally intrudes into waking consciousness. During REM, the brainstem actively inhibits motor neurons throughout the body, preventing us from physically acting out our dreams. This protective mechanism, called REM atonia, is almost universally present during dreaming. When a person becomes aware of this state while it is still active, they experience sleep paralysis. For many people, this is disorienting. For those pursuing WILD, it can be a recognized waypoint, a moment to move through calmly toward full dream entry, rather than away from an alarm. Research into the neurochemistry of lucid dreaming has pointed particular attention toward acetylcholine, a neurotransmitter that plays a central role in REM sleep generation. Acetylcholine is produced in large quantities during REM by neurons in the brainstem, particularly in regions called the pedunculopontine and laterodorsal tegmental nuclei. These acetylcholine-releasing cells essentially activate the cortex while simultaneously suppressing norepinephrine and serotonin, the neurochemicals associated with waking alertness. Some researchers have proposed that the relative balance of these neurotransmitters during REM may influence the likelihood of achieving lucidity. The interplay of these quiet chemical signals, drifting through the brain while you sleep, shapes the very texture of the dream world. The phenomenon of false awakenings, dreaming that you have woken up while still asleep, is closely related to lucid dreaming and shares some of its neurological characteristics. In a false awakening, the dreamer believes they have genuinely returned to waking life. They may get out of bed, begin their morning routine, and notice nothing unusual until some small anomaly, a light switch that does not work, a room in the wrong place, triggers the recognition that they are still dreaming. False awakenings and lucid dreams often occur in sequence, and experienced lucid dreamers use reality testing habits as a safeguard against being deceived by their own dreaming mind's reconstruction of ordinary life. The spatial and narrative architecture of lucid dreams is generated by many of the same brain systems that construct waking perception. The visual cortex, auditory cortex, and somatosensory regions all show activity during dreaming that closely resembles their activity during actual sensory experience. When a dreamer sees a mountain in a dream, the visual cortex responds in ways nearly identical to those produced by looking at a real mountain. When a dreamer hears music, the auditory cortex activates. The brain does not simply replicate the world. It reconstructs it, working from memory, pattern, and expectation. In a lucid dream, the dreamer can sometimes observe this construction process, noticing how a scene stabilizes when attended to directly and dissolves at the periphery of awareness. A study led by researchers at Northwestern University, published in the journal Current Biology in 2021, established something few had thought possible: a two-way conversation with a person inside a lucid dream, conducted in real time. The dreamers, sleeping in a verified state of REM, heard questions posed by researchers, incorporated them into the unfolding dream narrative, and signaled their answers using pre-agreed eye movements or facial muscle contractions. 4 independent laboratory groups in the United States, France, Germany, and the Netherlands conducted parallel versions of the experiment using different methods, and all arrived at the same conclusion. The sleeping mind could listen, reason, and respond. Correct answers were recorded on 29 separate occasions across 6 of the 36 individuals tested. The implications of that real-time communication finding are still being absorbed by the scientific community. Prior to this work, the study of dreams relied almost entirely on retrospective reports. What the dreamer remembered and chose to describe after waking. The accuracy of those reports has always been uncertain, subject to the fragmentary quality of dream memory and the reconstructive tendencies of waking cognition. Real-time signaling offers something entirely different. A window into the dream as it unfolds. Without the distortions of awakening, researchers are now asking whether this method could be used to explore aspects of dream experience, emotional tone, narrative content, sensory quality, that could never be accessed through memory alone. Simply let that possibility settle quietly. Dream control, the ability to deliberately shape, alter, or navigate the content of a lucid dream, is a separate capacity from lucid dream awareness and does not always accompany it. Many people who achieve awareness within a dream find that the dream continues along its own trajectory, resisting conscious direction. Others develop the ability to stabilize the dream environment, choose a direction of travel, or summon specific imagery through focused intention. Research suggests that dream control, when it occurs, involves sustained prefrontal engagement, the same region responsible for executive function and goal-directed behavior in waking life. The more consistently that region can maintain activity during the dream, the more deliberately the dreamer can interact with the dream world. Lucid dreaming has been studied as a potential tool for reducing the frequency and distress of nightmares, particularly in populations experiencing post-traumatic stress. The core of this application is straightforward in concept. A dreamer who recognizes they are in a nightmare can intervene in its narrative, redirecting its content or simply reminding themselves that they are safe within a dream. Imagery, rehearsal, therapy. A widely studied behavioral treatment for nightmare disorder involves consciously rewriting a recurring nightmare during waking hours and rehearsing the new version before sleep. Combining this approach with lucid dreaming techniques has shown promise in several clinical investigations, though large-scale randomized controlled trials remain in progress. The relationship between lucid dreaming and creativity has attracted considerable research interest. Anecdotal accounts from artists, musicians, and writers have long described using dreams as creative sources, and lucid dreaming, by allowing conscious engagement with the dream environment, may amplify this capacity. A study published in Dreaming, the Journal of the Association for the Study of Dreams, found that frequent lucid dreamers scored higher on certain measures of creative cognition, particularly on tasks involving divergent thinking. Whether lucid dreaming encourages creativity, or whether creative individuals are simply more likely to pursue lucid dreaming, remains an open question. What is clear is that the dreaming brain has access to associative patterns and imagery combinations that waking cognition rarely allows. Motor learning during lucid dreams has become an area of genuine scientific interest. A study led by Daniel Erlacher and Michael Schriedel, published in the International Journal of Sports Psychology, found that practicing a physical skill during a lucid dream, in this case, a coin-tossing task, produced measurable improvements in real-world performance, though the gains were smaller than those achieved through equivalent waking practice. The finding is not entirely surprising. The neural pathways activated during dreamed movement closely mirror those activated during actual movement, as established by neuroimaging research. The motor cortex, the cerebellum, and the supplementary motor area all respond during imagined and dreamed motor activity in ways that partially replicate physical execution. The therapeutic potential of lucid dreaming extends beyond nightmares. Researchers have explored its possible role in managing chronic pain, with some evidence suggesting that lucid dreamers can modulate the intensity of pain within the dream environment in ways that carry mild carryover effects into waking experience. The mechanism proposed involves the top-down regulation of pain signals by the prefrontal cortex during the lucid state, the same region that, in waking life, enables cognitive pain management strategies. While this research is still early and preliminary, it points toward a broader possibility that the heightened metacognitive state of lucid dreaming may allow a degree of conscious influence over systems that ordinarily operate entirely outside voluntary control. Tibetan Buddhist monks, practicing a form of advanced meditation called dream yoga, have described achieving and sustaining conscious awareness within dreams for centuries. Long before Western sleep science developed the tools to study it, dream yoga is part of the Vajrayana tradition and involves using the dream state as a practice ground for recognizing the constructed nature of all experience, including waking life. The Dalai Lama has spoken about these practices, and in recent years, several researchers, including those affiliated with the Mind and Life Institute, have begun formal studies of long-term meditators to understand how contemplative practice alters the neurophysiology of sleep and dreaming. This ancient tradition and modern science are finding, quietly, that they have been asking the same question. Children tend to have lucid dreams more frequently than adults, and the reasons for this are not entirely understood. Some researchers suggest that children's sleep architecture includes proportionally more REM sleep, offering more opportunity for lucid dreams to arise. Others propose that the boundaries between imagination and reality are more fluid in childhood cognition, making the transition to awareness within a dream less disorienting and more naturally occurring. There is also the possibility that the prefrontal cortex, which continues developing through adolescence and into early adulthood, engages with dreaming differently at different stages of maturity. Though the relationship between frontal development and lucid dream frequency has not been definitively established, there's nothing to hold on to here. Simply let it drift. And here, at the quarter mark of our journey, the shape of something larger is becoming clear. Lucid dreaming is not simply an interesting curiosity of sleep. It is a meeting point between neuroscience, psychology, philosophy, and the deepest questions we can ask about awareness. Each fact has quietly built upon the last, tracing a path from ancient accounts and early experiments through brainwave research and two-way communication and therapeutic promise. The question the title poses, what is the science behind lucid dreaming, is already beginning to answer itself. But the answer is richer and more layered than a simple list of mechanisms. We are only halfway through the evidence. Let us pause here and breathe. Let's pause here and notice your body. As you breathe out slowly, appreciate each quiet process happening inside you. Trillions of tiny processes working in silence. Neurons firing in the dark. Memories being sorted. Sensations arriving and dissolving without effort. Notice the gentle weight of your limbs, the rhythm of your breath moving softly through you. You are a complete ecosystem, always balancing, always renewing. Even now, even here, there is nothing you need to do. Simply notice, simply rest. Now we continue. The neural correlates of lucid dreaming have been refined significantly by modern neuroimaging. A 2025 study using high-density EEG, drawing on data pooled across multiple laboratories worldwide, found that the transition from ordinary REM dreaming to lucid dreaming was marked by increased connectivity between the prefrontal cortex and the temporoparietal junction, a region associated in waking life with self-other distinctions, perspective-taking, and the sense of being located within a body. Beyond what we explored in the early facts about the prefrontal cortex alone, this finding suggests that lucid dreaming involves a specific kind of self-referential awareness, the recognition that the experiencing self is distinct from the experienced environment. It is, in a subtle sense, the brain recognizing itself. The temporoparietal junction's involvement in lucid dreaming connects to a broader understanding of how the brain constructs the sense of self. In waking life, this region integrates information from the body's physical sensations, visual input, and the internal sense of being an agent within space. Damage to this area has been associated with out-of-body experiences, the sensation that one's self has separated from one's body and floated to an external viewpoint. Some researchers have noted similarities between out-of-body experiences and certain features of lucid dreaming, particularly WILD-type transitions, and have proposed that both states involve disruptions to the normal integration of self-referential information. The self, it appears, is assembled rather than simply given. Serotonin and its relationship to dreaming has been examined in light of lucid dream research. During ordinary REM sleep, serotonin activity is strongly suppressed, one of the defining neurochemical signatures of the REM state. Some researchers had initially proposed that this serotonin suppression was responsible for the loosened associative logic and reduced self-awareness of ordinary dreaming. The evidence here is complex and still evolving. What is clear is that the neurochemistry of lucid dreaming involves a delicate balance among multiple neurotransmitter systems, and that interventions which tip the balance too far in any direction tend to disrupt dreaming rather than enhance it. Allow that complexity to rest gently in the background. You don't need to hold on to it. The default mode network, a set of brain regions that activates during rest, self-referential thought, mind wandering, and the imaginative reconstruction of past and future, plays a role in dream generation that researchers are still mapping. This network, which includes the medial prefrontal cortex, the posterior cingulate cortex, and the angular gyrus, is highly active during ordinary REM sleep. Its activity during lucid dreaming has been found to differ qualitatively, with the medial prefrontal node associated with self-monitoring, showing stronger and more focused activation, while posterior regions associated with passive experience remain equally engaged. Lucid dreaming may represent a state in which the default mode network's self-referential capacity is gently turned back on, while its narrative and imagery generation continues uninterrupted. There is nothing to do with that. Simply let it pass. Heart rate and respiration during lucid dreaming differ slightly, but measurably from those recorded during ordinary REM sleep. Studies have documented mild increases in heart rate, coinciding with the onset of lucidity, consistent with the increase in frontal arousal associated with becoming aware. These physiological changes are small, far less pronounced than those observed during full waking, and do not typically disrupt the sleep state. They do, however, confirm that the lucid state is genuinely distinct from surrounding REM sleep, not merely a subjective impression, but a physiologically distinct mode of brain and body function. The sleeping body is changed, however gently, by the mind's awareness of itself Individual differences in lucid dream frequency have been linked to several psychological and cognitive traits. Researchers have found associations between frequent lucid dreaming and higher scores on measures of absorption. The tendency to become deeply and fully immersed in mental activities, whether imaginative, perceptual, or aesthetic. Frequent lucid dreamers also tend to score higher on openness to experience, a broad personality dimension associated with curiosity, aesthetic sensitivity, and comfort with ambiguity. Some studies have found associations with better spatial working memory and stronger metacognitive monitoring ability. The capacity to observe and evaluate one's own thought processes while they are occurring, lucid dreaming, in this sense, may be both a product and a further development of these qualities. The role of intention in lucid dreaming cannot be overstated. Across multiple laboratory and naturalistic studies, one of the strongest predictors of achieving a lucid dream on a given night is whether the individual went to sleep with a clear, sincere intention to become lucid. This finding aligns with broader research on prospective memory, the cognitive system that holds future-directed plans and activates them at the appropriate moment. When a person sets a genuine intention before sleeping and vividly rehearses the anticipated experience of becoming aware within a dream, they are, in effect, planting a prospective memory cue that can activate during the altered state of REM sleep. The dreaming brain honors intentions more faithfully than many people expect. A growing body of research has explored whether lucid dreaming frequency can be reliably increased through training programs. A 2016 study published in Dreaming compared 5 different lucid dream induction techniques across a large sample of participants and found that a combination of wake back to bed, day, and reality testing produced higher rates of lucid dreaming than any single technique alone, or than no intervention. More recent mobile application-based studies, using in-app reminders to prompt reality testing throughout the day, have shown modest but statistically meaningful increases in lucid dream frequency in participants who adhered consistently to the protocol. The takeaway is consistent. Practice matters. And patient. Consistent practice compounds over time. The content of lucid dreams differs in characteristic ways from non-lucid dreams. Dream researchers analyzing content reports from verified lucid dreamers have noted that lucid dreams tend to be longer, more visually rich, more emotionally positive, and more narratively coherent than ordinary dreams. The dreamer's sense of agency, the feeling of choosing rather than simply experiencing, changes the emotional coloring of the dream environment. Fear, which is among the most commonly reported emotions in ordinary dreaming, becomes less dominant when the dreamer is aware they are safe within a dream. Joy, curiosity, and wonder become more prominent. The presence of self-awareness appears to shift not just the cognitive quality of the dream, but its emotional atmosphere. Light, in particular its behavior, is one of the most reliable indicators that something unusual is happening within a dream. Lucid dreamers frequently report that dream light behaves differently from real light. It does not follow consistent rules of reflection. It emanates from unclear sources, and it shifts without apparent cause. Some lucid dreamers use anomalous light as a reality cue. If light behaves strangely, the probability of dreaming is higher. This sensitivity to light behavior reflects the brain's attempt to simulate a coherent visual environment from incomplete information. The visual cortex, generating the dream scene from memory and pattern matching rather than actual photons, inevitably introduces inconsistencies that waking vision rarely produces. You can let that image settle softly. The concept of dream stabilization is important for anyone who has experienced the abrupt end of a lucid dream. The sensation of the dream dissolving as waking awareness begins to intrude. Experienced lucid dreamers have developed techniques to prolong the dream state when they sense it beginning to fade, including rubbing the hands together within the dream, spinning in place, or firmly directing attention toward the sensory texture of the dream environment. These practices appear to work by re-engaging the sensory and attentional systems that generate the dream, effectively reinforcing the neural activity responsible for maintaining the state. The act of focusing attention on the dream world, gently, without grasping, stabilizes it. Pharmacological research into lucid dreaming has focused primarily on compounds that increase available acetylcholine, the same neurochemical pathway we touched on earlier in our journey. A double-blind, placebo-controlled study of galantamine, an acetylcholinesterase inhibitor, conducted by Stephen LeBurge and colleagues, and published in the journal PLOS-1 in 2018, found that participants who took galantamine during a midnight wake-back-to-bed window had notably higher rates of lucid dreaming than those who took a placebo. With a dose of 8 milligrams producing lucid dreams in approximately 42% of participants on at least one night during the trial. The study was careful to note that galantamine is a prescription medication in many countries and carries potential side effects. And these results should not be taken as a recommendation for general use. Beyond pharmacology, light-based devices designed to support lucid dreaming have a long research history. The Nova Dreamer, developed through the Lucidity Institute in the 1990s, was a sleep mask equipped with motion sensors that detected REM sleep and then delivered gentle light flashes directly into the closed eyes of the sleeper. The intention was for these light signals to be incorporated into the dream, appearing as flashing lights, a pulsing environment, or an unusual visual event, and to serve as a cue that triggered lucidity. Results were variable across studies, but laboratory verification of at least some successes established the principle. External signals can penetrate the dreaming mind and gently influence its content. The concept has been revisited in more recent consumer devices, with mixed evidence of effectiveness. Transcranial alternating current stimulation, a method of delivering weak electrical currents to the scalp to modulate cortical activity, has been investigated as a possible tool for supporting lucid dreaming. A 2014 study by Ursula Voss and colleagues applied 40 Hz alternating current stimulation to the frontal cortex during REM sleep and found a meaningful increase in self-reported dream lucidity in the treated participants compared to controls. While this finding attracted considerable interest, subsequent attempts to replicate it have produced mixed results, and the mechanisms by which externally applied currents might influence subjective dream experience remain incompletely understood. Science, in this area, is proceeding thoughtfully and carefully, and here, at the midpoint of our evidence-gathering phase, the picture has deepened considerably. We have moved from the basic definition of lucid dreaming through its neural signatures, its induction techniques, its neurochemical underpinnings, and now into early territory of experimental intervention. What is emerging is something more than a single answer to the question of what lucid dreaming is. It is an entire field of inquiry still in formation, with genuine open questions, genuine debates, and a sense of a frontier not yet fully charted. Let that thought settle gently now. There is more to come, and it will grow quieter as we go. Take a slow breath. Notice how your body feels a little softer now, a little further from the day that preceded this moment. We are traveling through the science of dreaming together, you and I, and every quiet listener in the dark. There is no rush, no destination except rest. Let's continue. Gently. Dream characters. The figures that appear and interact with the dreamer behave in ways that reveal much about the brain's social simulation systems. In ordinary dreams, characters appear to act autonomously, sometimes unpredictably, often in ways the dreamer would not consciously generate. In lucid dreams, these characters sometimes respond to questions, offer information, and even claim to have their own perspective on the dream. Researchers have interpreted this as evidence that the brain runs sophisticated social models even during sleep, simulating the behavior and potential responses of others using the same neural machinery that supports theory of mind in waking life. When a dreamer asks a dream character a question, they are, in a sense, consulting a deeply embedded social simulation. You can let that thought drift past softly. The emotional regulation effects of lucid dreaming have attracted growing clinical interest beyond nightmares. Some researchers propose that the ability to maintain awareness and agency during a lucid dream may allow a dreamer to engage difficult emotional content from a position of metacognitive stability, rather than being swept along by the dream's emotional current. This parallels techniques used in established psychological therapies, where mindful observation of difficult thoughts or feelings, without being overwhelmed by them, can gradually reduce their emotional charge. Whether this mechanism operates similarly in the dream state, and whether lucid dreaming could complement existing approaches, are questions currently under investigation at several research centers. There is nothing to solve with this tonight. Simply allow it to pass. Time perception within lucid dreams is a subject of ongoing curiosity and some investigation. Anecdotal accounts from lucid dreamers frequently describe time feeling differently within the dream, sometimes compressed, sometimes expanded, occasionally seeming to move at a pace unrelated to real elapsed time. Laboratory studies in which lucid dreamers estimated the passage of time by performing tasks of known duration have found that time estimation in lucid dreams is broadly accurate, though somewhat elastic at the extremes. Long tasks tend to feel slightly shorter than their actual duration. Very brief actions may feel slightly longer. The dreaming brain's subjective clock runs, but not on exactly the same mechanism as its waking counterpart. Reading and language in dreams present a persistent puzzle. Most dreamers report that written text in dreams shifts, blurs, or changes when reread. The same sentence rarely appears the same way twice. Language processing in the left hemisphere, including Broca's area and Wernicke's area, is thought to be somewhat less consistently active during REM sleep than during waking, which may account for the instability of dream text. Spoken language within dreams, however, can be remarkably fluent. Dream conversations often feel natural and spontaneous. The asymmetry between written and spoken language in dreams reflects the different neural substrates these modes of language rely on, and their different patterns of activity across sleep stages. Pain within dreams is less common than sensory experience in other modalities. Some studies suggest that pain occurs in roughly 1% of ordinary dreams, a notably low proportion, given that pain is a constant feature of waking sensory experience. The suppression of pain during REM sleep may be related to the decreased activity of norepinephrine, a neurotransmitter involved in pain signaling, or to the reduced engagement of the anterior cingulate cortex, which processes the affective, unpleasant dimension of pain. In lucid dreams, some practitioners report a greater ability to modulate or dissolve pain imagery when it does arise, perhaps reflecting the increased frontal engagement that characterizes the lucid state. You can let that rest quietly now. The relationship between REM sleep and emotional memory processing has been extensively studied by researchers including Matthew Walker at the University of California, Berkeley. Walker's work has proposed that REM sleep strips the emotional charge from difficult memories while preserving their factual content, a process he has called sleep therapy. During REM, the amygdala, which generates fear and threat responses, is active. But the stress, neurochemicals, norepinephrine, and cortisol are at their lowest levels of the 24-hour cycle. This combination may allow the brain to reprocess emotionally charged memories without re-traumatization. If lucid dreaming can engage this REM window more consciously, it raises the possibility of a more deliberate form of emotional processing during sleep. Cross-cultural research on dreaming suggests that lucid dreaming, while described differently across traditions, appears in human experience worldwide. Indigenous traditions across South America, Africa, and Oceania describe practices that closely resemble what Western science now calls lucid dreaming. Intentional navigation of dream states for purposes of healing, guidance, and creative problem solving. The Achua people of Ecuador, for instance, practice systematic dream sharing and reflection as a cultural institution, treating dreaming as a form of meaningful communication with dimensions of experience beyond ordinary waking. This universality suggests that lucid dreaming is not a product of a particular cultural context, but a feature of the human brain, available to any mind sufficiently primed to notice it. Memory for lucid dreams, compared to memory for ordinary dreams, tends to be better preserved upon waking. Researchers attribute this to the heightened frontal activity during lucid dreaming, since the hippocampus and prefrontal cortex work together to encode episodic memories, and both are more engaged during lucid dreaming than during ordinary REM sleep. The resulting memories are more detailed, more sequential, and more emotionally specific. Lucid dreamers who practice recording their dreams report noticeably richer recall of lucid episodes than of matched non-lucid dreams from the same night. This improved memory encoding is itself a research tool. It means that the data lucid dreamers provide about their dreams is more reliable than the fragmentary accounts available from ordinary dreaming. Research into the relationship between meditation and lucid dreaming has grown steadily in recent years. A 2024 study published in the journal Brain Sciences found that specific styles of meditation practice, particularly those emphasizing meta-awareness and mindful observation of moment-to-moment experience, were significantly associated with higher rates of spontaneous lucid dreaming. The proposed mechanism is intuitive. Meditators train themselves to observe the stream of experience without being swept away by it. And that habit of watching, cultivated over years of quiet practice, appears to extend into sleep. The waking skill of noticing becomes, in time, the sleeping skill of knowing one is dreaming. You don't need to hold that. Simply let it be. Halfway through our journey, the answer to the title's question is becoming multidimensional. The science behind lucid dreaming is not one thing. It is the convergence of neurophysiology, cognitive psychology, contemplative tradition, pharmacology, and phenomenology. It is the story of a brain attempting to know itself in the very act of dreaming. Every technique we have examined, every brain region we have visited, every cultural tradition we have touched has added another layer to the same central picture. Awareness is not a fixed state, but a spectrum, and the sleeping mind travels further along that spectrum than we generally assume. Let the question rest gently with you now. The answers will continue to arrive, growing softer as we go. Each memory you carry from today was reconstructed the moment you recalled it, gently rewritten, slightly different from the version before. Your brain is always composing rather than simply recording. And tonight, in the quiet space between waking and sleep, that composing slows. The pressure of needing to remember, to understand, to hold, simply releases. You are already in the process of becoming tomorrow's rest. And we continue the journey. The insula, a region folded deep within the lateral sulcus of the cortex, plays a role in lucid dreaming that has only recently begun to receive dedicated attention. The insula processes interoceptive signals, sensations arising from inside the body, including heartbeat, respiration, and the felt sense of emotional states. During ordinary dreaming, the insula's activity is variable. During lucid dreaming, studies have found elevated insular engagement correlating with heightened bodily self-awareness, the dreamer's sense of occupying a body within the dream space. This internal sensing may be part of what grounds the dreamer's identity within the dream, providing a continuous felt sense of self that supports the metacognitive shift of recognizing one is dreaming. Allow that awareness of your own body to settle softly now. Lucid dream research has contributed to a broader reconceptualization of sleep itself. For much of the 20th century, sleep was characterized primarily by what was absent from it: consciousness, memory encoding, voluntary movement. The discovery that certain dimensions of waking awareness, self-recognition, intentional communication, goal-directed behavior, can persist during verified REM sleep has required sleep science to think more carefully about what sleep actually is, rather than a simple binary of on and off, sleeping and waking. The field now speaks of sleep as a complex collection of states, each with its own neurophysiological signature, each supporting different cognitive and restorative functions. Lucid dreaming sits at one edge of this continuum, a liminal state that belongs fully to neither waking nor ordinary sleep. The phenomenon of prelucid dreaming describes a transitional state in which the dreamer begins to question whether they are dreaming, often prompted by something unusual in the environment, but does not achieve full recognition of the dream state. The dreamer may think, "This feels like a dream," or "This cannot be real," without completing the logical step of concluding, "I am dreaming." This hesitation may reflect the partial engagement of prefrontal monitoring during a phase of REM sleep, where full frontal activation has not yet been reached. Some researchers view prelucid dreaming as a developmental stage in learning lucid dreaming, a sign that the metacognitive machinery is stirring, even if it has not yet fully awakened. Perhaps that stirring is enough for tonight. The relationship between waking absorption and dreaming extends beyond personality traits into specific activities. Researchers have found that people who engage in deeply immersive activities before sleep, reading fiction, playing narrative games, meditating, report elevated rates of lucid dreaming and more vivid dream content in general. The proposed mechanism involves the activation of the same imaginative and self-monitoring systems that support absorption in waking life, priming those systems to remain partially engaged during the transition into sleep. Reading before bed, in particular, has been associated in some studies with richer dreaming. Perhaps because narrative fiction directly exercises the same storytelling machinery the sleeping brain uses to construct dreams. Dream incubation. The deliberate practice of setting an intention for specific dream content before sleep has been documented across cultures and studied in modern sleep labs. Participants instructed to think about a specific topic, image, or problem before sleeping do show increased rates of dreaming about that topic compared to control nights, though the effect is variable and not guaranteed. During the hypnagogic period, the imagery-rich transition between waking and light sleep, content from waking thoughts frequently surfaces in distorted or fragmented form. Thomas Edison famously exploited this transition deliberately, holding small metal objects as he dozed so that the sound of them falling would wake him and allow him to harvest the imagery at the edge of sleep. You can let that image drift gently now. The architecture of a typical night of sleep provides naturally increasing opportunities for lucid dreaming as the night progresses. A person sleeping 8 hours will cycle through 4 to 5 REM periods. The first REM period, occurring roughly 90 minutes after falling asleep, lasts only 5 to 10 minutes. By the fourth and fifth cycles, REM periods may extend to 45 to 60 minutes each. The final 2 hours of an 8-hour sleep period are dominated by REM, which is why the early morning is the most fertile time for vivid dreaming, and why the wake back to bed method is so effective. Simply sleeping long enough, not interrupting sleep at the end of the night, substantially increases exposure to the stage where lucid dreaming most naturally arises. Animals other than humans may experience something resembling dreaming. REM sleep has been identified in all mammals studied and in birds. Rats, whose sleep architecture has been studied by researchers including Matthew Wilson and Kenway Louie at MIT, show hippocampal activity during REM sleep that closely mirrors the activity patterns recorded while the rats were navigating a maze during waking hours, suggesting they are, in some sense, replaying the day's experiences. Whether any animal experiences something analogous to dream awareness, a watching of the dream rather than simply inhabiting it, is unknown. The neural requirements for self-referential metacognition may or may not exist in other species in forms we would recognize. The question, for now, remains open and gently unanswered. The connection between nightmares and REM sleep reveals something important about the emotional function of dreaming. Nightmares are intense, negatively valenced dreams that typically arise during REM, and they are associated with activation of the amygdala, the brain's primary threat detection center. Nightmare disorder, defined by the American Academy of Sleep Medicine as recurrent nightmares causing clinically meaningful distress, affects roughly 4% of adults. Post-traumatic stress is associated with a particular form of nightmare that replays traumatic events with high fidelity. and in which the normal emotional processing function of REM sleep appears to break down. Lucid dreaming. By offering a pathway to awareness and intervention within the nightmare, addresses this breakdown at its source, gently. The glymphatic system, a waste-clearing network in the brain that flushes cerebrospinal fluid through channels formed by glial cells, is most active during sleep, particularly during slow-wave sleep. While the glymphatic system's primary activity occurs during NREM sleep, there is evidence that REM sleep contributes through its own mechanisms of cerebral blood flow and pressure changes. Research in this area is ongoing, and the specific role of REM, and by extension of lucid dreaming, in the brain's nightly clearing process remains to be precisely characterized. What is established is that the sleeping brain is engaged in active restoration, not passive waiting, and that the quality and duration of sleep has measurable effects on this restorative process. The sense of time in ordinary dreams is notoriously fluid. Dreams that feel like hours may occur in minutes of clock time. Conversely, very brief hypnagogic images at the edge of sleep can contain what feels like extended narratives. These patterns are not random. They reflect the brain's use of narrative compression, a strategy it employs both in dreaming and in memory consolidation, to create coherent storylines from fragmentary material. In lucid dreams, time perception is somewhat more accurate, likely because the prefrontal engagement that supports lucidity also supports more realistic time estimation. But even in lucid dreaming, the sense of time bends, and experienced lucid dreamers often note that the dream world does not feel quite bound by the same temporal rules as waking. Research on lucid dreaming and the sense of self has touched on questions that philosophers have considered for centuries. Questions about personal identity, about what makes you the same person across time, take on a vivid quality when considered from within a lucid dream, where the continuity of identity is simultaneously present and obviously constructed. The dreaming self knows it is dreaming and yet continues to feel like a self. It persists. It reasons. It chooses. And yet everything it perceives is generated from within. Some philosophers of mind have proposed that lucid dreaming offers the closest naturally occurring approximation to philosophical thought experiments about consciousness. A case of being aware while the world around you is demonstrably not what it appears. Perhaps that is enough to wonder about. Gently. Lucid dreaming has a documented effect on the vividness of waking imagination. People who practice lucid dreaming regularly report improvements in their ability to visualize deliberately during waking hours, to form and hold detailed, stable mental images. This connection may reflect shared neural pathways between voluntary visual imagination and the dream generation process. The visual cortex, the parietal cortex, and the frontal systems involved in executive imagery all contribute to both waking visualization and dream construction. Training one appears to influence the other, a finding that aligns with research showing that mental imagery practice can improve performance on visual tasks, even when no physical practice is involved. The role of narrative in dreaming is one of the most underexplored areas of sleep science. Dreams are almost universally experienced as stories rather than as random fragments. They have characters, settings, tensions, and resolutions. Even when these are unusual or incoherent by waking standards, the brain appears to organize even the most fluid dream material into a narrative form. applying the same story grammar structures that govern waking comprehension of events. Lucid dreamers, with their greater narrative awareness, sometimes report being able to observe this construction process, sensing the dream forming around them, watching a setting materialize from indistinct shapes, noticing how attention and intention influence which narrative direction the dream takes. Recent interest in large-scale dream data has been driven by mobile applications that prompt users to record their dreams immediately upon waking. Projects studying thousands of dream reports from participants worldwide have enabled analyses of dream content at a scale impossible in laboratory settings. Findings from these datasets confirm patterns observed in earlier classical content analyses. Dreams reliably contain more negative than positive emotions, more social interactions than solitary events, more familiar faces than strangers. Lucid dreams, when identified within these datasets, show the expected pattern of more positive affect and more agency. The scale of these modern datasets has given dream science a new kind of mirror. You can let that rest softly. The neuroscience of lucid dreaming is beginning to intersect with research on consciousness disorders. Conditions such as vegetative state, minimally conscious state, and disorders of awareness following brain injury. The finding that awareness can persist during sleep in the form of lucid dreaming has informed thinking about what forms of awareness might be present in patients who show few external signs of consciousness. Researchers studying covert awareness, hidden consciousness not apparent from behavior, have borrowed methodological tools from lucid dream research, particularly the use of voluntary eye movements as indicators of inner awareness. The work of these two fields, running in parallel, has quietly begun to illuminate each other. The concept of wake-state misidentification describes the tendency, in both ordinary and lucid dreaming, for the brain to fail to correctly identify its own state. In ordinary dreaming, the brain consistently misidentifies the dream as waking reality, a failure of metacognition so complete and so consistent that it is arguably the default operation of the sleeping mind. Lucid dreaming represents the correction of this misidentification, a moment when the brain accurately perceives its own state. What makes this noteworthy is not that lucid dreaming is exceptional. It is that ordinary dreaming is the state in which a sophisticated brain routinely mistakes its own constructions for an external reality. Allow that gentle paradox to drift by now. The hypnagogic state, the period of transition between wakefulness and sleep, is often rich with imagery, sounds, and fleeting narrative fragments. Researchers studying this state have found that it involves a unique form of mental activity, more fluid, more associative, and more visually vivid than ordinary waking thought, but not yet the fully constructed narrative of a dream. Many creative individuals have described the hypnagogic state as a source of unusual connections. The chemist August Kekulé reportedly conceived the ring structure of benzene from a hypnagogic image. The hypnagogic state shares neurological features with both waking and REM sleep, and some researchers view it as a brief window of awareness before the more complete architecture of dreaming takes over. The question of whether dream consciousness constitutes genuine phenomenal experience, whether there is something it is like to be in a dream, in the same sense that there is something it is like to see color, is a live question in philosophy of mind. Most researchers who study dreaming take for granted that dreams are phenomenally real while they occur. But the constructedness of dream experience, the fact that everything in it is generated by the brain from within, has led some philosophers to wonder whether the standard criteria for consciousness apply straightforwardly to the dreaming state. Lucid dreaming, in which the dreamer can reflect on and report their experience from within it, provides the most unambiguous evidence that dreaming involves genuine consciousness. Simply let that settle now. Physical sensations in lucid dreams can be extraordinarily vivid. Touch, temperature, texture, pressure, and proprioception all appear within the dream with a quality that dreamers frequently describe as indistinguishable from waking sensation. The somatosensory cortex generates these experiences using stored sensory memories and pattern completion mechanisms. When a lucid dreamer touches a surface in the dream, the somatosensory cortex responds in ways that closely mirror its response to actual touch, which is why the experience feels real. This vividness is both the most captivating feature of lucid dreaming for many practitioners and one of the most philosophically layered. If a sensation generated entirely by the brain is subjectively indistinguishable from an external one, what criterion distinguishes the real from the dream? You can gently let that question go. The effect of daytime emotional experience on dream content and lucid dream frequency has been examined in several studies. Higher levels of unresolved emotional concerns are associated with more emotionally intense dreaming and disruptions to the REM architecture that supports lucid dreaming. Paradoxically, mild positive engagement, such as that associated with curiosity, creative activity, or a satisfying conversation, appears to support richer and more memorable dreaming without disrupting sleep architecture. This suggests that the emotional state carried into sleep is not neutral with respect to dreaming. The mind brings its residue from the day, and that residue shapes the dreams that follow. Allow the day's residue to settle now. There is nothing left to carry into this rest. Research on children who have experienced prolonged stress has found elevated rates of both nightmares and lucid dreaming compared to controls. Some researchers interpret this as evidence of an adaptive mechanism. The sleeping mind attempting to process overwhelming experience may recruit metacognitive resources as a form of self-protection, generating lucidity as a way of maintaining some sense of agency within the dreaming state. If this interpretation is correct, lucid dreaming in these circumstances is not a disruption, but a spontaneous form of dream regulation, an attempt by the brain to find safety within an otherwise overwhelming dream environment. The mind, even in sleep, looks for ways to take care of itself. The experience of déjà vu, the sense that a new experience has been lived before, may share neural mechanisms with certain features of lucid dreaming. Both states involve a kind of double awareness. The immediate experience of what is happening now, combined with a simultaneous meta-awareness that something unusual is occurring in the relationship between memory and perception. Research on déjà vu has implicated medial temporal regions, the hippocampus, parahippocampal gyrus, and perihinal cortex, that support the integration of current experience with stored memory, and that are thought to contribute to the recognition processes underlying lucid dream onset. The feeling of recognition, this is not what it seems, may be a shared signature of both states. Allow that quiet familiarity to drift past now. In recent years, researchers have begun to explore the overlapping features between lucid dreaming and certain altered states induced by substances acting on the serotonin system. Both states can be characterized by vivid visual imagery, altered self-perception, and a loosening of the ordinary boundary between self and environment. The overlap is not identity. The mechanisms differ, the contexts differ, and the subjective texture differs in important ways. But the shared territory between these states has prompted researchers to ask what they reveal, in combination, about the range of conscious states available to the human brain. This is an area where research is very early. Proceeding carefully and without haste. Simply let it be. The neuroscience of attention during lucid dreaming reveals something about how the dream world is held together. In ordinary dreaming, attention moves fluidly and without deliberate direction. The dreamer is carried along by the dream's narrative momentum. In lucid dreaming, voluntary attention becomes possible. The dreamer can choose to look at something carefully, to focus on a specific feature of the dream environment, or to direct their gaze deliberately. This voluntary attention appears to be sustained by the same frontoparietal network, involving the dorsolateral prefrontal cortex and the inferior parietal lobule, that supports directed attention in waking life. The return of voluntary attention in lucid dreaming is, in miniature, the return of one of the defining features of waking consciousness. And now, gently, you can release it. And here, with 25 facts remaining, the intellectual answer to the title's question has taken full shape. What is the science behind lucid dreaming? It is the science of the brain recognizing itself, the convergence of metacognitive monitoring, prefrontal arousal, temporal parietal self-modeling, and the ancient neurochemistry of REM sleep into a moment of singular clarity within the dream world. Lucid dreaming is where consciousness becomes aware of its own dreaming, where the architecture of the mind becomes, briefly, visible to itself. The remaining facts will take us somewhere deeper and quieter still, toward what all of this means, not just scientifically, but humanly. Dreaming does not try to happen. It simply does, unfolding in its quiet cycles, night after night, patient and unhurried. And you are part of that cycle. Your breath, your thoughts, your slow movement towards sleep, all of it unfolding in its own perfect order. You don't need to hold on to anything tonight. Not a single fact, not a single thought. Let everything move at the pace of your breathing, and let your breathing slow. We are nearly there now. The sleeping brain is never truly quiet. Even in its deepest stages, neural activity continues, signals passing, patterns forming, memories consolidating in slow, rhythmic waves. Sleep is not the absence of mind. It is a different mode of mind, one that waking life rarely allows us to visit with awareness. Every night, the prefrontal cortex steps back from its waking role, loosening the grip of reason and self-censorship. The result is dreaming, a state in which the mind creates freely, without the constraints that define waking thought. Lucid dreaming invites reason gently back in. Without closing the door that dreaming opened, the human brain devotes roughly 25% of every night to REM sleep. Over a lifetime of 75 years, that amounts to more than 50,000 hours of dreaming. Most of that time is spent in a world the dreamer does not know is a world. The possibility of knowing, of being present in that vast interior space, is what lucid dreaming quietly offers. People who are born blind from birth do not have visual dreams. Those who become blind after a period of sighted experience may retain visual dreaming for years, with the visual content gradually fading over time. Those blind from early childhood dream primarily in sound, touch, smell, and proprioception. Whatever senses are most developed in waking life, the dreaming brain builds its world from the sensory materials it actually possesses. The most common setting in dreams, across cultures and demographic groups, is a familiar interior space, a room from childhood, a home associated with safety, a recurring environment of no particular drama. The dreaming mind returns to familiar territory instinctively, building its nightly worlds from the residue of where we have felt most at ease. There is something quietly comforting in that, a deep conservatism to the dreaming imagination. Allow that sense of the familiar to hold you gently now. Voices in dreams, including the dreamer's own internal voice, arise from the same language processing regions active in waking. The voice of a dream character and the voice of the dreamer's own thoughts are both generated by the brain, indistinguishable in mechanism, though experienced as entirely separate. In lucid dreams, the dreamer's inner voice gains a quality it often lacks in ordinary dreaming: continuity, intention, and the ability to form gentle questions. The body does not move during REM dreaming. The voluntary muscles are held in almost complete stillness by the brainstem's atonia mechanism. And yet, within the dream, the body moves freely, runs, climbs, dances, floats. The sensation of movement is generated entirely by the brain's motor simulation systems, without a single muscle contracting. The dream body is a construction, and for the duration of the dream, it feels entirely real. Recurring dreams, those that return in similar form across months or years, appear with particular frequency in people experiencing prolonged stress or unresolved emotional concerns. They seem to represent the sleeping mind's attempts to process material that waking strategies have not fully resolved. In lucid dreams, recurring scenarios can sometimes be gently interrupted and redirected. The dreamer, recognizing the familiar landscape, can choose a different turn in the story's path. Some lucid dreamers report the ability to float or fly within dreams. One of the most commonly described and most peacefully pleasurable experiences associated with lucid dreaming. The experience is generated by the vestibular system, which tracks the body's orientation in space, combined with the visual cortex's generation of moving aerial imagery. The brain constructs flight, not from imagination alone, but from the same systems that manage real balance and real vision, which is part of why dream flight feels so physically genuine. Allow yourself to imagine it softly, for just a moment. The transition from dreaming back to waking is, for most people, unmarked, a sudden shift from inside the dream to outside it, with no perceptible moment of passage. For some, particularly those practicing lucid dreaming, the transition becomes noticeable, a gradual brightening, a thinning of the dream's texture, a growing awareness of the physical body lying still. This threshold, like the threshold into sleep, can be observed, and in observing it, something changes about how both sides of it appear. Across cultures, dreaming has been understood as a form of encounter with the self, with others, with something beyond ordinary experience. Modern neuroscience has not ended this understanding so much as translated it. What were once described as messages or visions are now understood as the brain's own meaning-making. Its nightly effort to process the residue of experience and generate coherent story from the fragments of a life. The mechanism differs from the interpretation, but the significance the dreaming mind attributes to its own productions does not diminish. The quality of a lucid dream is often described by practitioners as depending entirely on their state of mind at the moment of achieving lucidity. Lucidity, achieved in a state of calm and openness, tends to produce vivid, stable, and richly detailed dreams. Lucidity, achieved in a state of grasping or urgency, tends to produce unstable dreams that quickly dissolve. This parallels a principle familiar in contemplative traditions. Awareness held lightly tends to persist. Awareness gripped too tightly collapses. The dreaming state opens, like sleep itself, to the one who simply allows. There is something the lucid dreaming literature calls the paradox of control. The more a dreamer tries to control the dream world directly, through force of will, the more resistant and unstable the dream becomes. Control achieved through soft intention, through a kind of gentle invitation rather than demand, tends to be more reliable. The dream world, like the sleeping mind that generates it, responds differently to different qualities of attention. Gentleness, it turns out, is more effective than force, even within the landscape of one's own consciousness. The last thoughts before sleep, the images, words, and feelings that drift through the hypnagogic space at the edge of consciousness, are among the most influential inputs to the night's dreaming. Sleep researchers refer to the residue of waking day carried into dreaming as the day residue, a term Sigmund Freud introduced in his early work on dream interpretation, long before neuroscience could examine it. Modern dream content analysis has confirmed the phenomenon. The concerns, conversations, and images of the recent waking hours appear with elevated frequency in the dreams that follow. The last thing you gently attend to before sleep has a disproportionate influence on where the dreaming mind goes. So could the science of lucid dreaming change how we understand consciousness? It already has. The simple fact that awareness can exist simultaneously with the dreaming brain's construction of a world, that the mind can watch the mind dreaming, has required neuroscience to reconsider what it means to say that someone is asleep, and what it means to say that someone is aware. The boundaries are not where they appeared to be, and in that quiet realization lies something more than a scientific finding. It lies a shift in how we understand what we are. The practice of keeping a dream journal, writing or recording dream content immediately upon waking, is one of the most reliably effective foundations for lucid dreaming development. Even without any other technique, consistent dream journaling increases dream recall, builds familiarity with personal dream patterns, and trains the metacognitive habit of reflecting on dreaming. Over weeks and months, a dream journal becomes a record of a second life, one lived in the same mind, in the same body, during the same nights, but largely invisible without the quiet habit of noticing. The lucid dream state has been described by many practitioners as among the most vivid and meaningful experiences available to human consciousness. Researchers studying the phenomenology of peak experiences have noted that verified lucid dreamers frequently rate their most significant lucid dreams as among the most memorable events of their lives. Not merely pleasant, but genuinely meaningful. The sleeping brain, it appears, is capable of generating experiences whose value extends beyond the night in which they occur. Simply let that possibility rest gently with you. The science of lucid dreaming is young. The formal laboratory study of the phenomenon is less than 50 years old. The neural correlates are still being mapped. The clinical applications are still being tested. The full range of techniques is still being characterized. What is already clear, from the eye movements and the brainwave research and the real-time dialogues and the therapeutic possibilities, is that the sleeping mind is far more available to awareness and far more open to influence by awareness than a century of sleep science had assumed. The findings in this field are not finished yet. In the final minutes of a lucid dream, as the dream begins to thin and the waking world begins to reassert itself, there is often a moment that experienced practitioners describe as particularly clear. A brief interval in which both worlds seem equally present, the dream and the waking, and the dreamer occupies the threshold between them. This threshold is not distressing. It is, by most accounts, extraordinarily peaceful, a moment of being nowhere quite yet, suspended between one state and another, belonging fully to neither. It is, in a sense, the most conscious moment of the sleep cycle. The deepest answer to what lucid dreaming is may be simpler than all the science surrounding it. Lucid dreaming is awareness finding itself in the dark, the mind, mid-dream, turning its own light gently back toward the source of the light. Every person who has ever woken within a dream and thought, "I am dreaming," and felt the strange doubling of that recognition, has touched something that science is only beginning to name. The experience precedes the explanation, and the explanation, however detailed, does not quite exhaust the experience. What remains, after all the words, is the quiet fact of having been aware within a dream, and that fact belongs entirely to you. The ancient Tibetan teachers who developed dream yoga said that all of waking life could be understood as a dream from which we have not yet become lucid. Science does not endorse this as literal fact, but as a pointer towards something real, toward the constructed nature of perception, the interpretive nature of memory, the selectivity of attention. It is not without foundation in what neuroscience has come to understand about how the brain generates experience. All experience, waking and dreaming alike, is constructed. Lucid dreaming simply makes the construction briefly visible. Tonight, as you rest, your brain will enter REM, sleep. Neurons will fire in patterns that generate imagery, narrative, emotion. Characters will appear. A world will form, complete, convincing, and entirely internal. And somewhere in the quiet machinery of that dreaming, the possibility exists, as it exists every night, of a small light of awareness turning on within the dream. Not tonight necessarily, perhaps not for a long time, but the capacity is always there. The door is never fully closed. Research continues. Neuroscientists are refining the neural map of the lucid state. Clinicians are testing its therapeutic potential. Philosophers are considering what it reveals about the nature of mind. And dreamers, ordinary, curious, restful dreamers, are practicing their reality checks, setting their intentions, waking gently in the early morning hours to whisper to themselves, "The next time I am dreaming, I will remember that I am dreaming." In this way, science and personal experience meet, in the dark, in the quiet, at the edge of sleep. The question the title poses has been answered in many dimensions over the course of this journey. The science behind lucid dreaming is the science of awareness itself, of how the brain monitors its own states, constructs its own worlds, and occasionally, in the deep of the night, catches itself in the act of dreaming and pauses to notice. That pause, that moment of inner recognition, is what makes lucid dreaming not just a curiosity, but a window into the oldest, most intimate question. What is it to be aware? And perhaps the most beautiful answer science has offered so far is this: awareness does not sleep. It changes shape. It moves from the sharp, deliberate attention of waking hours to the fluid, narrative attention of dreaming. And in lucid dreaming, it briefly holds both forms at once. The watcher and the dreamer become the same. The one who dreams and the one who knows they are dreaming look at each other across the threshold. And for a moment, there is only one. That moment is what 100 facts have been quietly pointing toward. And now, it is time to rest. And so, our quiet journey through the science of lucid dreaming comes to a gentle close. We have traveled from the first laboratory proof of awareness within a dream, those deliberate eye movements recorded on a sleep monitor in April 1975, all the way to the fragile, extraordinary moment when a dreaming mind turns, recognizes itself, and briefly holds both sleep and waking in a single hand. We have touched the updated landscape of brainwave research, where earlier certainties about gamma waves are giving way to a more nuanced and more honest picture. We have visited ancient Tibetan practices and modern laboratories in France, Germany, the Netherlands, and the United States. From the first fact to the last, the same thread ran through everything. Awareness is stranger, more persistent, and more available than we tend to assume. Lucid dreaming reminds us that the mind is not simply what it appears to be during the daylight hours. Much of its most remarkable work happens in the dark, in the silence, in the spaces between waking thoughts. The dreaming brain is not resting. It is processing, constructing, healing, and on the rarest of occasions, watching itself do all of this with quiet astonishment. By pausing to learn this, by taking one night to listen, you have glimpsed something most people never pause to notice: that the world inside is as vast and as real as the world outside. In these final minutes, take the deepest breath you can, as deep as possible. Think about awareness itself, yours, right now, in this quiet room, moving gently towards sleep, and the awareness of every dreamer tonight, all across the world, some of them already in their first REM period, some of them beginning to dream, a few of them, perhaps, becoming lucid within their dreams, briefly knowing they are dreaming, and then softly releasing even that knowledge as sleep deepens. You are not separate from that. You are part of the same vast, quiet process. Let your entire being dissolve into the space between waking and sleeping, where thought becomes image and image dissolves into rest. No boundaries left, only peace. Prepare for deep sleep. Exploring the dreaming mind together tonight has been a gentle kind of gift. A soft like, subscribe, or share could guide another curious mind to this same quiet space. Someone out there right now who might need exactly this. One peaceful night. One sleepy soul at a time. But there is nothing to do now. Nothing at all. You have traveled far tonight. Not across distance, but inward, through the architecture of a mind that never truly stops working, even in its deepest rest. You can allow these thoughts of dreaming to fade now, like the last image of a dream dissolving at the edge of waking. Not lost, simply returned to wherever images go when we stop looking for them, leaving only a soft and unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if the patient gravity of a long night has found you here and is simply holding you. If sleep comes, let it carry you the way a dream begins. Not with effort, not with force, but with the quiet arrival of something that was already on its way, into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they are closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the dreaming brain will still be there, still cycling, still processing, still holding the possibility of that quiet inner light. The awareness that survives even sleep will still be there, patient and unhurried. But tonight belongs to stillness. Rest well, dear traveler, and remember, even in the deepest dark, the mind that watches never truly goes out. Good night.